Hello viewers, welcome back to another section of my tutorial, and in this video we're going to solve a multivariable calculus problem. This problem happens to be under partial derivatives. So I have a function f of x which is equal to cos of 4 out of x multiplying the expression e to the power x squared y minus 5y to the power 3. So we are supposed to find the partial derivatives of this function. Kindly watch this video to the end so that you understand every part of the video. And if this is your first time visiting this channel, don't hesitate to subscribe and also like. How do we go about this? I have a trig function and an exponential function multiplying each other, and we want to find the partial derivatives of this. So first of all, under partial derivatives, we're going to find fx and also find the fy, where fx is our derivative with respect to x and fy is our derivative with respect to y. So in this case, what I'm going to do is we are going to take one after the other. So we are going to find the fx, that is derivative with respect to x first. So how do you do it? We are going to differentiate this expression with respect to x, meaning any other thing which is not x is going to be a variable. So if it's not x, then it's going to be a variable. So let's see how we're going to do it. So I'm having cos of 4 over x, then e to the power x squared y minus 5y cubed. So this is a product rule because it's the product of two different functions. We have a trig function as well as an exponential function. So to differentiate this with respect to x, I'm going to differentiate this term and maintain this, and afterwards add the product rule. So product rule says that if you have a function, let's say you have f of x to be equal to u v, where u is one function, v is another function, your f prime of x will simply be equal to u prime v plus u v prime. That is, you will differentiate the first one, then you leave the second one, then after you leave the first one, then you differentiate the second one. That is the rule. So in this case, we are going to differentiate this one and maintain this. So how do we differentiate this? This happens to be a composite function. So if you have cos of 4 over x, you want to differentiate this, we are going to take what we have here and make it, let's say, u, or let's say p. So let p be equal to 4 over x. So to differentiate the p over the x, I'm going to have what? This is 4 to come out. Then if you have x to the power 1 over x is the same as x to the power negative 1. So I'm going to get negative 4 over x squared. That is the inner function here. Then if I'm going to be left with cos p. So cos p, if I differentiate cos p, I'm going to get negative sine p. Therefore, the total derivative of cos, that is cos of 4 over x is prime, is simply equal to negative sine p multiplying negative 4 over x squared. And this still further simplifies to, our p is 4 over x, so I'm going to get negative and negative to cancel to give us positive, and I'm going to get positive sine, where my p comes 4 over x, then multiplying 4 over x squared. So that is actually the derivative of cos of 4 over x. So I come back to what I'm having. So I'm going to get sine of 4 over x multiplying 4 over x squared, then e to the power x squared y minus 5y cubed. So I have differentiated this and I've left this. So this plus, so the second part, we are going to differentiate this and we leave this. So I'm going to write my cos 4 over x here. Then I'm going to differentiate this with respect to what? X. So let's see how we're going to do that. So if you have e x squared y minus 5y cubed, and I want to differentiate with respect to x, the y and all the things it become constant. Further again, I'm going to make q to be equal to my exponent x squared y minus 5y cubed. So if I find the q over the x, then I'm going to get 2xy. This place remains 0. So for that reason, I'm going to multiply what I'm having here by 2xy. Then after, I bring the q back to the function. So let's see. Our function becomes e to the power of q. So the derivative of this is still e to the power q. Therefore, e to the power x squared y minus 5y cubed, all prime, that is the derivative of this whole term, is equal to 2xy multiplying e to the power q, where q is what? X squared y minus 5y cubed. So therefore my solution becomes cos 4 over x 2xy e to the power x squared y minus 5y cubed. So writing my final answer, my f of x, or fx, sorry, that is partial derivative with respect to x, is simply equal to sine 4 over x squared e to the power x squared y minus 5y cubed plus cos 4 over x 2xy e to the power x squared y minus 5y cubed. This is the partial derivative with respect to x. Let's go to the fy, partial derivative with respect to y. How do we do that? So if I have my function to be cos 4 over x e to the power x squared y minus 5y cubed, and I want to differentiate it with respect to y, meaning this whole thing is a constant. My x squared here is a constant, so I'm going to focus on this alone. So therefore, I'm going to tackle this function. So let's see, let's r to be equal to x squared y minus 5y cubed. So finding the r over the y, I'm going to get here, what is x squared minus 15y squared. That is, I'm differentiating with respect to y. So here y will go, leaving this as a constant, minus 15y squared. Then I'm going to get e to the power r. When I differentiate, I'm going to get e to the power r. So it remains. Therefore, the derivative becomes x squared minus 15y squared multiplying e to the power x squared y minus 5y cubed. That is for this part alone. Then this, since is a constant, I'll add it towards. So therefore, I'm going to get my fy to be equal to cos 4 over x squared minus 15y squared, also in another bracket multiplying e to the power x squared y minus 5y cubed. So as the question asked us to find the partial derivatives, and it says first order partial derivatives, meaning we have to differentiate it once. So the partial derivatives are the fx and the fy, differentiated with respect to x and with respect to y. So we did our fx here, and now this is our fy. Thanks for watching this video. More tutorial videos on partial derivatives will be posted. Don't forget to subscribe, like, and also share.